Okay, this problem was in a magazine in 1990, and it caused all kinds of chaos, and it still is actually causes all kinds of chaos. It was a proposed game that was based off of a game back in the 80s called Let's Make a Deal, and the person that hosted that game's name was Monty Hall. So this game is based off of that TV show game. It's called the Monty Hall problem. Here's how the game worked. The game would allow you to have three doors. So they had three doors. And the TV show had a really good prize and then two really bad prizes. So the bad prizes were donkeys and the good prize was a car. And they let you pick one. So you could pick maybe that door right there. And if you get whatever's in that car. So the TV show would let you pick it, and then they would always show one card or one door that was the donkey. So I'm going to let the twos represent the donkeys, and I want to represent, so the twos are the bad prizes and the ace is the really good prize. So this is the car and these are the donkeys. So they would mix them up. So we mix them all up like this and mix them up and put them out there. Okay, so they would allow the user to pick a door. So let's just say we pick this door right here. The TV show would show, oh, aren't you glad you didn't pick that one because that was a donkey? And so then the contestant is really happy. Yay, I'm glad I didn't pick this one. Now I have maybe I have a better chance of winning. So then the game show host would ask one more question. Would you like to trade? Would you like to trade your door? Would you like to go like this instead? Would you rather have this one or would you like to keep your card? And the article asked the question, is there any advantage? Is it just 50-50? If you trade, is it just 50-50? Or is there some kind of advantage? Most people psychologically keep their card. So that person would have won a donkey because the car was over here. Okay, get the idea? So whatever the arrangement is, you pick one. The TV shows a bad one, so aren't you glad? So they take that one out. And now should you trade? That's the question. Should you trade? Well, we could play this game a little while and just always keep the card we have and see. So if I keep it, oh, lost. Reshuffle. Okay, reshuffle. I'll just keep picking the same door. And they say, oh, aren't you glad you didn't pick this one? And throw it out. And now they ask, do you want to keep your door that you picked already? So most people would say yes, and a win. So far it's been 50-50. The first time I lost by keeping my card. This time I won by keeping my card. So we keep doing this some more and more and more. I'll just keep picking the same door. They say, oh, aren't you glad you didn't pick that one? Take that one out. And now the question remains, should you keep your card or should you switch your card? So if we keep our card, we got a donkey. So I played 3 times. 2 times I got a donkey, 1 time I got a car. So we would expect if we just keep playing this over and over and over again, is it 50-50 or not 50-50? So maybe I'll switch it up this time. Maybe I'll pick this one this time. Okay, they say, oh, aren't you glad you didn't pick this one? Throw it out. Do you want to switch your card or keep your card? Okay, I kept it. So I won 2 cars and I've won 2 donkeys. Looks like it might be 50-50. That's the game. The question is there any advantage? Let's say they show us this one. Is there any advantage to switching, or would it just be 50-50 since there's only 2 cards left? That's the question. And the editor of the magazine said there's definitely an advantage one way or the other. And people argued for years over that there can't possibly be an advantage. Well, let's try something. So I have this app right here that basically plays that game. So behind the 3 hidden doors is 1 car and 2 donkeys. So let's play a couple times and just see what happens. I'm going to pick this one right here. And how about we keep the door? So here we could either keep it or change it. Let's play 10 games and just see what happens if we always keep. So I'm going to pick door number 1. They show me, aren't you glad you didn't pick door number 3? And now I get to change or keep. I could trade it for door number 2, but I'm going to keep it. Okay, so I lost. I won a donkey, a goat. So see, it's keeping score. I have 1 goat and 0 cars. Okay, let's try again. How about I pick door number 2 this time? Okay, they're showing me the loser. I could either keep 2 or change it for 3. I'm going to keep door number 2. Okay, yay, I won a car. This time out, so it's 50-50. 1 car, 1 goat. This time I'll pick door number 3. I see this is a loser, so I can either keep 3 or change it for 2. I'll keep door number 3, and I kept the donkey, the goat. So I got 2 goats and 1 car. Okay, I'll pick door number 1. I'm going to keep door number 1. Okay, I kept the goat. So I have 3 goats and only 1 car. I'll pick door number 2. I'm going to keep door number 2. Okay, I kept a goat. So I got 4 goats and only 1 car. I'll pick door number 3. Okay, I'm going to keep door number 3. Okay, good. I kept a car. So now I have 4 goats and 2 cars. Play door number 1. I'm going to keep door number 1. I kept a goat. 5 goats, 2 cars. I'm going to pick door number 2. I'm going to keep door number 2. I kept a goat. 6 goats, 2 cars. I'm going to pick door number 3. I'm going to keep door number 3. I kept a goat. 7 goats and 2 cars. I'll pick door number 1. I'm going to keep door number 1. And I kept the car. Okay, so we did 10 games. I only won 3 times. So 3 out of 10 by keeping. Okay, let's compare that. Now I'm always going to change. Let's play 10 more, and I will change. So how about I pick door number 1? Now, instead of keeping door number 1, I'm going to trade for door number 2. So I'm going to change. So that was a bad trade. I had the car, and I traded it for a goat. So now I have a goat. Maybe you just lose this game all the time. Okay, I picked door number 2. I'm going to trade it for door number 3. A goat. Lost again. Okay, I'm going to pick door number 3. I'm going to trade for door number 2. Okay, really bad. Okay, I will have 3 goats. Door number 1, I'm going to change for door number 3. Finally, I won a car. I'm going to pick door number 2. I'm going to trade it for door number 3. Okay, I won a car. I'm going to pick door number 3, but I'm going to trade it for door number 1. Okay, I'm making a comeback, 3-3. I'm going to pick door number 1. I'm going to trade it for door number 2. Bad trade. Pick door number 2. I'm going to trade it for door number 1. Good trade, 4-4. I'm going to pick door number 3, and I'm going to trade it for door number 1. Bad trade. Going to pick door number 1, and I'm going to trade it for door number 2. Bad trade. So it looks like we're just going to lose all the time. So if I trade, the house has the advantage, and if we keep, the house has the advantage. So playing 10 of these, it doesn't really look like there's any advantage at all. The problem with that is we haven't really done enough trials. So this problem caused a lot of stir in 1990, where this problem was written up in a magazine, and the magazine's math editor said you have a much better chance by trading every single time. Well, maybe we had a tiny better chance, but that looks like that could have just been luck versus non-luck. Well, the nice thing about this app is we can try more than just 10 games. So that's what simulate means. I'm going to try 100 games, and I'm going to always keep the same door and let it add up down here what happens if we play 100 games really fast. So right now it's 0-0, and I'm going to play 100 games and always keep the door we picked. Here we go. It's just going to go fast, and you can see down here at the bottom, it's it's starting to, the goats are certainly winning. So by keeping so far, we've only won 10, 11, 12, 13 cars. We have 30 something goats. It sure looks like keeping our door is settling in on not such a good idea. It's trying to make a comeback, but never really did. Looks like 64 to 36. So we didn't do so well. This time, let's reset this up here to change. So let's go 100 times again. But this time, always change doors really fast, and we'll go 100 times and see what happens. So here we go. Okay, look at that. Now it looks like the cars are certainly winning. I have 25 cars to only 18, 19 goats. Looks like it's trending the other way. Certainly looks like it's settling in on. Okay, so it looks like I had an advantage if I would have traded, is 58% to 42%. So that's looking a little bit. Why didn't it go all the way up to 100 tries? That's only 97 tries. So it looks like the cars, though, we have a little bit of an advantage if we try to change, and that's what the guy said at the magazine. And people wrote in all the time, there is no way that can be true. It's 50-50. Okay, let's see if we can't figure out why that might be the case. Is there any way we can prove that? Okay, this is called a veridical paradox, and it's a result that appears absurd, but is demonstrated to be true nonetheless. Now, I'm going to show you a proof, but that doesn't mean that you're going to believe it. There's a lot of people that don't believe the truth. So here we go. Let's take a look at how that might have happened. Here were the good and two bads. Okay, the car and two goats. And we lay them out there, and you get to pick one. Okay, so we pick one, and then they show you a bad one, so the house knows where the bad ones are. So they show you a bad one, so they'll show you this one. That makes it look like now it's 50-50, because we just there's only two cards left. I can either keep or switch. But it's really not 50-50. The information of showing you doesn't help. What if we would do this? Showing you this information makes it feel like you're safe when you're really not. Let's do that again. Let's take this one. What if I didn't show you anything? Would you trade this one card for these two cards? Okay, well, if we're trying to win a car, of course, everybody would probably do that. I'll trade this one card for these two cards, and yes, I win. Okay, if I shuffle them up again, it doesn't matter which one we pick. Let's say we pick that one. If I don't show you, would you trade your pick for these two? Of course, everyone would say yes. And now we take a look, and we win a car. Of course, we would trade our one for our two, because we would have we would raise our odds to 2 out of 3 chances to win. Okay, if I shuffle them up again, if we pick this one, of course, we would always trade to try to win the car. Now, sometimes, see, we might lose, but we have raised our odds. If we don't trade, we only have a 1 in 3 chance of winning. If we do trade, we have a 2 in 3 chance of winning. Okay, let me shuffle these up again. Oops, shuffle them up again. Okay, now, I'm going to go ahead and pick one. Would you trade 2 for 1? Of course, everybody would. It doesn't matter that I show you this one is a loser. We would still trade 2 for 1. Even if I show you this one is a loser, we would trade. Showing you that one was a loser doesn't change anything. It was just information that made it look 50-50 when it wasn't. Now, there's always a loser. So I'll shuffle them up again. There's always a loser in the house. So even if I pick the winner, which I happen to know that one's the winner, but nobody else does, of course we would trade. Even if I show you a loser. Okay, so there was the loser. so we made a bad trade, but it was to our advantage to try to do that. So it doesn't matter if we pick the winner or we pick a loser, there's always one to show. If I take this one up, of course we would trade. It doesn't matter that I show you the loser. We would have still traded and we would have won. So it's 2 to 1. It's 2/3 to 1/3 in your advantage to always trade, because when they show you a loser, that doesn't change the math of the cards. The math of the cards was 2 to 1, whether you know this information or not. Knowing this information just makes it look 50-50 when it was really 2/3, 1/3. Okay, that's my first attempt at the proof. I have one more try. If that doesn't prove it, then let's do this. Okay, here are the 3 possibilities. Okay, bad, good, bad. All right, I'm going to draw this. I'm going to zoom in. I'm going to zoom in a little bit. So let's just say if we pick this one, we would be sad. If we pick this one, we would be happy. And if we pick this one, we would be sad. Okay, so let's think of our 2 possibilities. Right here, we picked the bad one and we're sad. Well, if we keep that bad card, we're still sad. But if we trade, we would become happy. Okay, or let's say we picked the car. Well, now if we keep the car, we would still be happy. And if we trade, we would have become sad. And if we picked the goat and we keep, we're still sad. But if we trade, we are now happy. Okay, look at the keepers. There's a keeper, there's a keeper, there's a keeper. If we are a keeping person, we are sad 2 out of 3 times. If we're a trade person, we are happy 2 out of 3 times. That's the math of the cards. Knowing that extra information actually doesn't help us. It gets us in trouble. So yes, oftentimes having extra information is false security. Of course, if we were to pick this one and we have no additional information, everyone would trade. But if we have a little bit of extra information, now it looks like it's 50-50, and most people would stay with their same card, when mathematically we should have traded and won the car.